try that again with some audio on. So good morning, good afternoon, wherever you are in the world. So for those of you who don't know me, my name is Cowley. I'm a developer experience engineer at Neo4j. But I am a Neo4j user for over 5 years now, I think. And so today, as a celebration of the Premier League coming back, I actually tweeted out today saying it was at this weekend, but it's actually tomorrow. So in celebration of that fact that the Premier League football is finally coming back, I thought I'd spend some time today working through some data, scraping some data from skysports.com using apoc.load.html. So apoc.load.html is something I didn't know was there until very recently. And actually, to be fair, it's really useful. So in the past, I've tried to pull in this data from various sources, and bringing data in from Wikipedia, bringing data in from sites like PremierLeague.com, from Sky Sports, BBC Sports, and things like that, and through APIs. One of the real problems with sports data is that it's really hard to get hold of unless you're paying money for it. So I'm going to be a little bit cheeky today, and I'm going to take some data from a website. So I've read up on this, and it turns out that the actual data in question, so the sports data, the scores and the results, all of that data is actually public domain data. So I don't need to go too much into the legal side of things. But yeah, so what I'm going to do is I'm going to use apoc.load.html to pull some data in from a website which holds all that data. And so first thing I'm going to do is I'm going to model the data. So I use a tool called Arrows to model the data. We'll get the data into a database, and then we'll start to scrape some data from a website. So like I say, apoc.load.html is something that I didn't know about until very recently. So that's the first thing. So the first thing I'll do is I'll create a new project, and I'll import some data into that. So for the people who don't know, this is Neo4j Desktop. It's a UI that allows you to manage multiple projects and databases inside Neo4j, and to switch between them as well. So it's a really useful development tool. So I've created my new project by clicking New there, and I created a new project. So I haven't given it a name at the moment. I can rename it whenever I need to. You then create a database, and then set a password. You can select the version of Neo4j that you're interested in. So I'm going to go for 404. Hopefully the server will find it. But yeah, and then what I'll need to do as well is add apoc to that. So by adding a plugin inside Neo4j Desktop, what it means is that for every database that you create from then on in, it will install that for each one. Cool, so I've done that, click start. And then once the database is up, I should be able to run that command again. So I guess as I mentioned a little bit earlier on, so this is something I've been trying to do on and off for maybe 4 or 5 years. So it'd be great to crack it now, and it'd be great to get the data and actually start to play around with the data in great detail. So before I was using a JavaScript library to do this. And basically, it took quite a lot of time. So what I needed to do was take the data I needed to transform it into to JSON, and then load it into Neo4j using JSON. So I took a few approaches. So one of the approaches was to use Neo4j, which is a OGM that I built for Neo4j. So essentially, what I had to do for this is to create models. So for each one of my databases, for each one of the data types, I'd have to create a new model, and then I could feed like a big JSON object through into Neo4j. So obviously there's some work that needs to be done there that we don't necessarily need to do. So I mean, looking at Mark Needham's blog recently, mhneedham.com. Let's try that again. So looking through Mark Needham's blog, I'd spotted this this blog post where he was basically taking the data from Twin4j, so This Week in Neo4j, it's a weekly newsletter that we send out, and just looking through, I realised that he was actually using apoc.load.html, and like honestly, I didn't know that this had even existed. To be fair, as you can see here, it's core apoc.load.html. So I'm not quite sure how long this has been in the library, but I mean this is a great example of for apoc. Is that there are so many things in there. There's over 500 procedures and functions. So that there could be things in there that you don't even know that they exist. So the first thing I did when I found out about this, so I used the apoc help procedure to find out some information about what it was. So I called apoc.help and then with HTML, and then it gives me the type of procedure and functions that are available, the name, the text, and then the signature for that either the procedure or function. So I can see from this that it's got a URL parameter and then what looks like a map of names and their jQuery. So I did a little bit of research. So if I looked at the apoc documentation, I actually found out how this worked and what the procedures meant. So the documentation link. So in the load HTML page. So essentially, what this map is for a particular name. You can create a CSS or a DOM query, some sort of DOM selector, and then what that does is that spits that information out inside the value that you yield from the object. And this is really useful. So before I was using things like Beautiful Soup or I can't remember the name of the Node.js library. Name escapes me, but anyway, so it took a lot of configuration to actually find what's going on. Whereas this, it loads it straight into a Cypher query, and then you can start to play around with it from there. So the goal is, what we're going to try and do today is to load the data from Sky Sports and load the fixtures there. So one of the things that I haven't been able to do before that I'd really like to do now is to create a script that I can just keep running and running to pull in the fixtures and results at any one time. So I'm going to write some Cypher and create some nodes and some structure in the graph, which will allow me to do that. So if you go to sports and then football, so you can see on here that we've got loads of information. We're not going to worry too much about everything on there at the moment. But the thing that we find interesting here is the scores that are down here on the left-hand side. So here, I think maybe just because of the current climate and everything going on, is that everything is there. So you've got the Liga results there, you've got fixtures for the Bundesliga, and then the Premiership. So right now I'm only really interested in the Premiership scores. So I can find that by using the navigation. So in the leagues and cups, I can go to the Premier League. And then its navigation here gives me the fixtures and then the results as well. So basically, what I want to do is create a structure that will find these links. So, for example, the Premier League fixtures and then Premier League results, and then load those in periodically. So, in order to build up a model for this, I'm going to use arrows. For the people who haven't we've never seen this before, so this is a tool that's been around for absolutely years and is really, really useful. So it allows you to draw graphs out. So we've got nodes here, we can draw out nodes and relationships, we can draw a structure. And then we can use the export cipher to then import that, or export the cipher so we can then import that model into Neo4j. You can use the export markup link, and that will allow you to share the model with other people, so they can copy and paste the model in, and then they can click save, and then it will appear from there. So basically, the structure that we have is kind of like a tree structure. So maybe we would, if we were looking at more sports, then we could have a sports node. But I think the root node for our structure, or the grandparent that we're going to use here, is the league, because we care about the league. And then, for example, if we're looking for data and data from years gone by, what we can do is then create seasons. So the terminology for football, for anybody that doesn't know, is we have leagues, and then we have seasons, and then we have fixtures. So it might be different depending on where you are in the world, but this is what I'm going to go with. Being English. So basically, what we want to do is we want to create a node, and that'll be ready for the competition. So in this case, we can take all of the competitions here. So we can take the Premier League Championship, League 2, which my team Swindon Town are in, champions, not for much longer. And we can take all of these, essentially, we can pull in all that data. Hopefully all of the layouts will be exactly the same, so we can just run as we go. So we have the Premier League here. So I could write a script that will pull that out, but I'm not going to worry too much about that at the moment. So we have for each of the leagues, we care about the results, and then the fixtures coming up as well. So what I will do is I will create a node there. So we'll give it a name, and we'll call it the Premier League. And then I want to hold the URLs that my scripts will then go and fetch a little bit later on. So the results URL will be this one here, so skysports.com/Premier League results. And then the fixtures, we can take that as well. Cool. And then if we wanted to look at the data over the years, which I think might be quite interesting, is we can take the seasons. So for example, let's say this season and last season. So there is a seasons drop down here, so we can do 2018 and 19 and 2019-20. So right now we only really care about 19-20. But ideally, what these scripts will do is they will allow us to pull in the 19-20 and then 18-19 fixtures as well. So I can say give this season a name. So the Premier League 2019 to 2020, and then the results URL will be the Premier League fixtures, and then the season on the end. And then the fixtures URL will be for fixtures. Cool. And I can take that again for 2018 to 2019. So 2000, just change the values in there. (2018 and 19). So from these seasons, let's pull that one out for the moment. What we'll then have is fixtures. So these could be grouped by game week or something like that. I guess one of the things that is a problem right now is that normally you would have seasons that maybe have like 38 weeks of the season, plus the playoffs for the lower leagues. But right now everything is thrown completely out of whack. With the rescheduling the fixtures due to coronavirus. So that's something that I don't think will be very useful for my model at the moment. So we'll just leave that out for now. But a fixture will have a kickoff time. Actually, let's see. So if we take one of these fixtures, for example, so Aston Villa, Sheffield Wednesday is the first game that'll happen tomorrow. So the information that we can get from this page, and the information that might be useful, is the home team and then the away team. So home team Aston Villa, away team Sheffield United. So the competition of the Premier League. So we already know that from the context of the graph where we'll be loading that from. So don't need to worry too much about that. But the date and time of kickoff is important to us, and also the venue. So that is information that is important. For the results, there will also be some extra information there. So, for example, we have the scorers, and then we have the actual scores for the teams. We have the attendance. Now, maybe some teams will perform better or worse under high or low attendances. That might be something useful. And then we have links here for example, the statistics. So we can pull that data down. So what is possession, what is the total number of shots and targets, goals, things like that. It doesn't go into too much detail. There may be another source where you can find extra data a little bit later on. But for now, this should be good enough. And then the teams as well, so we can see the lineups, who played, who came on, who came off, who scored, who got booked, yellow and red cards and things like that. So we can load all that data in. So that will all be useful there. So for the fixture itself, so we essentially we're taking this data from the top. So we've got the kickoff time there, which will be a date time. We would have the attendance, which would be an integer. And I guess that's kind of really all that we have based off that fixture. So the other kind of piece of information that we'd have inside there is we would have things like the relationships to the teams. So let's call that a team node. And this would be the relationship of home team. And then again for the away team, so the away team will then relate to another team. So there'll be 20 teams inside the Premiership for this year especially. So each of the fixtures will point to two teams, and then we can identify who's the home team or who's the away team by the relationship type. So that I guess for now the only thing that's sort of interesting there at the moment is the name. So that'd be a string for both the home and the away team. And cool. And yeah, so for the home team and the away team, so what we can do is we can have a score which is on the relationship. So we can say that the goals would be an integer, for example. And same for the away team. And then, so we'd say that the stadium is something that that exists in its own right. So we'd say, for example, that the fixture will be played at stadium, and that stadium may be the stadium for a particular team. Which is cool. So in terms of the statistics, so there'll be things that will be stored again against the teams that appear in that game. So for example, Leicester have got a possession of 64.6 in this game, and Aston Villa have got 35.4. And so these will be things that are specific to those teams. So I won't go into too much detail, but we'll say, for example, the possession. I'm checking that that's about right. Which would actually be a float because it's a fraction of a percentage, and etc. etc. So we can load all of the information from there and then pull that into the graph. Cool. So the first thing I will do is I will take a selection of this and then pull it into Neo4j. We'll basically just iterate on this as we go along. So I will pull certain pieces of information. So I want the competition. I want the 1920 season. And I don't want the fixtures at the moment because I'll load those in. And then it'll be 0 related to 1. We'll get rid of that old data. So now we have the Premier League, which is the competition, and then the season, which is perfect. So I guess the downside to this is we have to create the fixtures manually. But in theory, as we import the data in, we could just scrape another page and then take that competition in from there. But right now we have this this relationship here. And actually, one thing I've realized is that says related to. I think that's because I haven't got the relationship type in there. So has season. Cool. So what I will do is I will rename that inside the database. So competition to the season. I'll take that relationship. So what I'm going to do is delete that relationship and then create the competition has a season. Of this. Then if I refresh this again, the competition there in orange now has a season. Perfect. Cool. So now this is where the fun starts really. So as I said, so we're going to use apoc.load.html. So sorry, HTML. Cool. So yeah, my essentially what I need to do then is I need to go through and find all of the, for example, the seasons that don't have fixtures. So I can run this script over and over again, and then it'll pull through all of the upcoming fixtures, or I can do that with the results. So I could say, for example, when we're loading in fixtures or results, the fixtures will be something that that happens, maybe once a month, just to get if there are any postponed fixtures. Or anything that's been rearranged, then we may want to load that once. But the actual results will be something that we do weekly. So for the purpose of this query, what we'll do is we will pull any season which doesn't have a has fixture relationship, and then we can then load that data from the internet. So if I say, for example, match the season where not exists a relationship has fixture, I can return that limit 1, and that gives me this this node here. Cool. Yeah. So right now I'm interested in the fixtures and results. So what we'll do is we'll take the fixtures in this case. So I can say that I can call apoc.load.html with s.fixtures URL. And then I'll have some selectors in there. So if we take a look at this page, the second argument is a map of CSS selectors. So essentially what we're looking for is any link under here really. So if we take a look at these, and then we go up to yeah, so this level, so you can see that the fixed res __ item, so using BOM. Great. So, and then we've got the link inside there. So really what we're interested in at the moment is getting the URLs for the fixtures or the results. And then we'll load the additional data in from there. So if I look at the actual query that we're looking for this, so if I use query selector all, and then that was .fixres __ item. I can see there's 129 there, so just give me everything that I need. Cool. So I'm looking for the .matches link in there instead. So console.clear. If you run that again. So fixed res item and then .matches link. Cool. So that gives me 92 at the moment, which is good enough. That will give me some data to play around with. Cool. And that looks a lot better now. So I see it's not pulling in the this home drawing away odds. It's just giving me the fixtures themselves. That's perfect. Cool. So if I take that, that is now my selector. So I can say that my fixtures are this. And if I yield the value out of that procedure and then return the value, it should load me some data. So as you can see, so where I've added this fixtures link in there, fixtures selector in there, on that value I've now got fixtures as an object, and that fixtures is then an array of the elements that are inside there. So each of those elements has a tag name. It has a set of attributes which will be useful for the URL, and then they have the class name, and they have the actual text inside there. So right now it's not really useful, but later on that'll be useful there. So if I, for example, take the fixtures, so unwind value.fixtures as fixture. And then, for example, let's say what we're interested in is the ID of the fixture. So we've got a unique identifier there, and then we've got a URL there as well. So the ID, I guess we'll take that from the URL. So we'll take the last part from there, and then we can get the URL, which will be attributes.href. So if we return fixture.attributes.href as the URL, and then so what we need to do is then to split this URL to then get the value. So what we can say is we can take that fixtures.attribute.href. So we can use the split function. So if I go to the Cypher ref card, I can see the split function takes the original string and then a delimiter to split it by. So if I split this string and then by the slash, that should now give me an array of all of the values. So really I'm only interested in this last thing there. So you can see as well that's a string. So what I need to do is take the last of those items, and then I need to cast that to an integer as well as ID. So now I've got the ID, which is the last element, and that looks good for all of them. So now what I need to do is to create the node on the screen. Or create in the graph. So what I can do is say create a fixture, and then set the ID property to be this ID, and then this to be the URL. And then I need to create the relationship from the season to the fixture. So season as fixture to F, and I'll return everything. Cool. So now I've got the season and the fixture there. So if I look at the graph here, so now I've got the 92 fixtures all loaded in from the page, and then the one season. So each should now all connect up. So now if I take the first 25, we should now see, yeah. So we've got now got this hierarchy of the competition. That competition has a season, and then that season has many fixtures. So that's the first 25 nodes, so 23 fixtures. But if I do match F fixture and then return a count of F, then we have 92 fixtures there, which is perfect, exactly what was on the page. Cool. So then the next step is to take a fixture and then load the data in from the fixture there. So if I run this query again, because the season now has one or more fixtures, it will now basically return nothing. So this means that every time I add a new season, I can then refresh the page, and then it will keep loading the data in, which is perfect, exactly what we want it to be. Cool. So if I take this query and then save that, and keep that to one side. Cool. So we can do the same thing now with the fixtures. So for all of the fixtures there, we now have two properties there. So we have the ID, which is a unique identifier. It's fine. There's nothing too interesting about that at the moment. But then we have this URL. So for all of these fixtures, they only have one relationship at the moment, which is the has fixture relationship to the season. So you can use the same trick really to get all of the fixtures there that, for example, don't have a stadium or don't have a home team or an away team, or this so any of these relationships, and then we can load the data in, so we can scrape that data from there. So if I take a fixture where not exists, and then we say at stadium, I think I called that, played at. So where that is not played at, another node, and then return that limit 1. Of course, now we have the first one there. So that's this Aston Villa versus Sheffield Wednesday. Cool. So if we see the information that we would find useful for this fixture, so again, we've got the kickoff date and time, we've got the stadium, and we've got the two teams. So what we can do is we can then create the rest of the structure from there. So if we pin that to one side, and then put this on the other. So again, we can call apoc.load.html again with n.url, and then we'll define some selectors. Yield value, return value. So let's see what is interesting. So first we'll take the stadium. So basically what we want is this bit here. So we need to find some sort of selector that would allow us to pull that information in. So just by inspecting, we can see that actually it's in this SDC site match header detail venue. So it's inside there. So if we take a look at this, just to check what we're getting, so as a class. So that's the value that we have. So essentially what we want from inside there is the in HTML. And then I guess we want to do some cleaning up as well to make sure that that dot's not on there. Cool. So the selector for that is this here. So we can put that into this side. And then that will give us the stadium. So if we double check that, so we should now have value.stadium. I guess once it loads. So let's assume that's there for now. So with value.stadium O as the stadium. Essentially what we want to do is we want to take the string, but we want to have it for everything except the last character. So we can use the left function for that. So head over to the cipher card again. So we've got left. So the original string and then the sublength of that string. I don't know why it's not. Let's kill that. So we want stadium. So it's .text for the actual text that's held inside there. And then we want the length of stadium.text, and then minus 1, so we're taking 1 away. So with n limit 1. So I only take the first one. Oh, is it size? Cool. Perfect. So if I return the 2, then you should be able to see the difference there. Cool. So we've got the raw text is Villa Park with a dot on the end, and then we have it with it stripped out. So I just want to double check that actually, because with the fixtures and results, it may be different depending on the stadium. Yeah, so that's got a dot on there. Getafe Español. Yeah, okay, perfect. But what we could do actually is we could say we could run like a case statement, so kind of like an if statement to check that is still there. So we have the write function as well, which will give you the rightmost characters, the last characters in the string. So we could say, for example, case when I guess we could use the predicate as well. So where the string ends with a dot, then we could use left of the string with the size of the string minus 1. So if we try that on a couple of values, so if I use unwind to unwind to, so string 1, which has a dot, and then string 2, which doesn't, string, and I can return, so case when the string ends with a dot, then take the left of the string for the size minus 1, so it strips off the last character. Else just give me the string end as clean string. So now we've got them both. So we've got, just in case something happens there, if the format changes for whatever reason, then we're covered. So if I then go back, cool. So then I can replace that with this stadium.text. Awesome. So we'd still got that value there based on stadium with a dot at the end. Cool. So that's the first thing that we're interested in. Cool. Perfect. So the next thing is the kickoff. So this is going to be something that's kind of tricky to do. So I've tried to do this a few times, and it can be a little bit temperamental, let's say. In apoc, there's a function which allows you to convert the type, the date, a string into a date type. So if I just search on date, it should give me what I'm looking for. So it's date.convert format. So yep. So what this does is converts a string of one date format into a string of another date format. And so what we can do is we can take the string that we have there, and then we can then convert that into a date format. Cool. So this uses a datetime formatter in Java. So basically, we want the syntax from that in order to convert it. So these are the values that we have. So we just need to play around with those until we get the value that we're looking for. So if we say with 6 p.m. on 17th of June 2020 as the date, and then let's say, so we're going to return apoc.date.converts format from that date with the format that we have, and then the format that we want it in. So the Neo4j datetime so these were introduced in Neo4j 3.4. So basically, you can use like an ISO string to then convert a date or a string into a native datetime. So for example, if I take the datetime and then 2020 06/16, and then it's 1547 at the moment, 4700 with a T. So now we can see that's a date time there. So it's just converted that in, and it's taken UTC or Z as the time zone. So one thing that we don't have inside this is the time zone. So what we can do instead of the date times, we can use a local date time, and this basically just doesn't have the Z on the end. So it saves a little bit of space when you're storing it, but it's because we don't have anything to convert the format. It's the local date time of the fixture in that time zone, regardless of what that time zone is. Cool. So that is our format that we'll be converting into. So we want the 4-letter year, which would be YYYY. And then we want the month, which is uppercase MM, and then we want DD. And then we want to put like a literal character in there, so the T, so that's the T that we have there. And then we want the hours, minutes, and seconds in 24-hour format. So the hour of the day, 0 to 23, in this case is a H. And then we want lowercase double m for the minutes, and uppercase lower m for the S, for the seconds. Cool. So that's the format that we're interested in. And then, so now what we need to do is we need to decode this. So this is one I've made earlier, but don't worry, I'll go through and I will format it. So this is the format that we've got here. So we need to do a text replace. I'll go into that in a little bit more detail. But essentially, we're taking the kickoff value, so the text there, and then we're converting in from this format here, and then into this format. So the first part is so it's the 12-hour format of the date. So essentially, that is a H. And then we want MM. And then so for the PM, AM, PM is an A here. So AM, PM of the day for that. And then we have this literal character here. So we have the comma. So we add that in there. After that, there's a space. And then we want the long form of the day. So in this case, we've got Wednesday. And the format of that is EEEE. Which is this guy here, day of week. And then a space. And then the day of the month, which is lowercase d. And then the so the apoc text replace inside this is because there's no representation of the suffix of the number inside this. So basically what I do inside there is I use apoc.text.replace to actually remove one or two numbers, or in this case any number, followed by the values st, nd, rd, or th, so first, second, third, fourth, fifth, sixth, etc. So then it will convert the date into this format, so just 17. So that is what this bit here does. So if I hide this for a second, and then I just return what I'm doing there. So if I take the date and I replace this value with just the number in this case. So we're taking in there $1 is the first group. And I use a comma instead of a dot. So you see it's instead of 17th, it's 17 June, which is kind of what we want because we can't get the value from the datetime format. Cool. So what we want to do is we want to put apoc.date.convert format back in. And let's take the value back that we're working on. That's the second argument, and the third one is what we want to convert it to. Cool. So now we don't have that th, we've just got a space there instead. So then we want the long form of the month, so that is capital M, so month of year, which is the M there. So in the long format, that's MMMM, and we've got YYYY. And then a dot on the end, which is just a literal character. Cool. And then again, if I place the dot. Perfect, so that's the date that we're looking for, that's the format that we want. So then if I wrap that in a, local datetime, it will be formatted or inside like a pre-tag or a code tag. So that demonstrates that is now a date and time. So that should now work for all of the dates. Let's say Tuesday, I don't know, 3rd of May. I don't know if that's a date or not. But yeah, so it's got the 3rd of May there. Perfect. Let's try that at 6 a.m. Perfect, still works. Cool. So we'll take that. We'll put that to one side. And then we take that. That grey back. Cool. So the selector for that, if we take a look, is SDC site match header detail time. So let's call that kickoff. Cool. And if we say we call that as the stadium. And what we'll do is we'll put back in that case statement. Cool. And then we'll take the formatting of our date time. And we'll put that in as the give this a format. It's a little bit easier to read. Cool. Oh, yeah, and sorry, I need to replace that. So it's the value .kickoff. It's the first value, and this time it's .text because it's the text inside there. So let's take that out. Perfect. So the stadium is Villa Park. The kickoff is 17th of the 6th, 2020 at 1800 hours. Perfect. So the next things that we need inside that query are the teams, I suppose. Cool. So if we take a look at the teams, so the two team names there are Aston Villa and Sheffield United. Let's take a look at the selectors for those. So ideally, what we want is a selector that will give us both of the team names. So I guess in this case, it looks like a link, and then we can take the information from there. So if I inspect Aston Villa, so we've got SDC site match header team name block, and then yeah, we have the same thing for the away team. Cool. So if I take this value, so basically I'm looking for this, and then in theory that should give us a list, one array with two values. So document.query selector all. Yeah, so that gives me a node list with two values inside there. So those two are spans. So if I check, make an array out of those. Cool. So what I could do is I could use that the anchor tag that's inside there. to get the values. So the few things I can use on this. So I've got this data short name. I've got the URL, which is skysports.com/Aston Villa for Aston Villa. So I can use that data to then get the team names. Cool. So let's try that. So for the teams, that is the selector. Oh, so actually I used the wrong selector there. Cool. So that should give me the A. So then I can get the short name. I can get the value from the span inside there in order to get the team names. Cool. So I have my the teams inside there. So I want value.teams will give me two arrays essentially. So the first one, so index 0 will be the home team, and then value.teams1 will be the away team. Cool. So there you can see we've got a link there. So the tag name is A, so that's the link that we've got. We have the href, which you can take. We can use that as a slug or a unique identifier for the club. And then we've got the text there, which is the actual name of the team. Cool. So I can say attributes.href as home href, and then value.teams attributes o.text as let's call that the home name. And we can do the same thing for away, so the away href and away the comma there. Sorry, it's not attributes.text, it's just .text. Cool, so that gives us the stadium, the kickoff, the home ref, home name, array ref, and away name. Cool, so that should be enough data at the moment to actually create some structure and create some nodes inside there. So what we can do now is we can use these values to then create the data inside there. So what we want to do with that value is we want the from the fixture. Firstly, what we want to do is create a stadium, and then we'll create the relationship to the stadium. So one of the problems when you're pulling in the data from these different sources is that the data may be slightly different depending on where it's coming from. So if we did, for example, want to take some data from BBC Sport, or we want to take some data from PremierLeague.com, then there may be some slight subtleties. So one thing we can do is we can normalize the name property into an ID, and it will create like a unique identifier. So for that, we'd use apoc.text.clean, and then we can use that as the identifier. So we can say, for example, we can merge a stadium, and then say the ID of that is apoc.text.slug. So that will convert the property into slug case. So that'll be dashes and lowercase. So we can call that the stadium name inside there. Like I said before, what we want to do is we want to create a script that we can keep running and keep running. So if we use the create statement instead of merge here every time, we would always create a new stadium. But what we want is just a single stadium there. So what I can do is use the merge instead. It will merge on this ID. So this will be the unique value for that stadium, and then I can say on create set. And then set the properties from there. So it'll only set the properties once they're first created. If the node's already there, then it just ignores it and skips on to the next step. Cool. So we can set that to be the name, and then we want to merge the pattern of the relationship as well. So merge fixture, which is played at the stadium. So the next time I run this, the fixture that we're actually active on at the moment won't be there anymore because I've merged that that statement in. So therefore, it won't it will fail on that predicate essentially. Cool. And then so the next thing we want to do is we want to create the home team. So we'll merge home, which will node team, and again we'll do the same thing. We'll use apoc.text.slug. In order to create a unique slug for that. So the home name is this one here. We can use apoc.text.slug. And then we can say on create set home.url equals the home ref. And then home.name is the name. Cool. And then we'll merge the relationship there again. So from that end node, that fixture, home team is home. And we could do the same thing for the away team. We just change the zeros for 1 there, basically. And then we want to change home for away. So that looks good. So we've still got some properties as well that we haven't set yet. So we can set the n.kickoff value to be the local date time that we've converted. So we've used the kickoff time there, the local date time. We've used the stadium name to create a stadium node. We have used the home details to create the home team, and then the away teams to create the away details. So if I hit return star on this, and we remove the syntax error, we need an extra bracket. No, so yeah, let's tidy this up a little bit. That one's fine, that one's fine. It should be, oh. Let's take that out for now. So here we've got, so now that looks like we've missed a reference there, so we've called that something different. So so we called it F when it's actually N. So that's not. So I have to go back and clean that up at some point. So if we run that now, we've now got the fixture. The fixture has a home team, Aston Villa. The away team is, I missed that there. So the away team should be 1 there. Cool. So this is now a fixture, which is so West Ham versus Watford at the London Stadium. So if I take a look at that, that's good. So we can now start to import some data in from that. So once the check has happened, so once that data is gone, then we can go back to the result URL and we can pull the data in from there. Cool. So there's some cleanup for me to do there. So that is everything I got to show you today. So all this code I'll put up at GitHub at some point. I think next Tuesday, around about the same time, we'll come back and we can look at everything else. But that's it from me for today. If anybody has got any questions, any comments, feel free to reach out, join the Neo4j community forum, or contact me on Twitter. I'm at Adam Cowley on Twitter. Or if not, then just enjoy the Premiership coming back. Look forward to some live sport, and I'll speak to you soon. Take care.